The F-16 fighting Falcon can beat anything. Today's Air Force F-16 dates back as far as the 1970s, a circumstance which might lead some to wonder how the combat aircraft has sustained its combat relevance and performance capacity into the dynamic threat environment of the 2020s. The Air Force is giving its 1970s-era F-16 fighter jet F-35 technology as part of a massive fleet-wide overhaul intended to improve targeting, attack precision and computer systems, to extend the fighter's combat life all the way into the 2040s. It might be tough to imagine that today's Air Force F-16 dates back as far as the 1970s, a circumstance which might lead some to wonder how the combat aircraft has sustained its combat relevance and performance capacity into the dynamic threat environment of the 2020s. The answer is actually quite extensive and goes back many years to the inception and preservation of an F-16 service life extension program which upgraded the upper wing skin and fittings, adjusted the bulkhead and canopy and gave the aircraft an F-35 active electronically scanned radar, AESA. With AESA, the F-16 incorporated an entirely new ability to find, detect and track enemy threats at much greater ranges. The aim of the Service Life Extension program was to extend the flight time of F-16s from roughly 6,000 to 7,000 flight hours to 8,000 or more flight hours. On top of that, the service's confidence in the upgrades has led to a plan to have the F-16 fly all the way out to 12,000 hours. The active electronically scanned radar, which Lockheed developers say can track up to 20 targets at one time, is a massive upgrade beyond the F-16's previous mechanically scanned radar. By virtue of its ability to track multiple targets, the active electronically scanned radar can scan in a 360-degree sphere to include horizontal, vertical and diagonal vectors. Not surprisingly, the F-16 has also in recent years received new cockpit avionics to include moving map displays, video in the cockpit, digital graphics screens and new target tracking systems. Upgraded F-16s also use a high degree of increased onboard automation to free up pilot focus and workload. By automatically performing a range of important procedural functions independently, a pilot is then freed up to focus more intently on other mission-critical tasks. Alongside the Air Force Service Life Extension program, Lockheed Martin has also been building a new F-16V variant, which continues to inspire allied interest around the globe. The F-16V also uses new computers and software as well as a high-definition cockpit display. The V model also adds a new data bus, electronic warfare suite, missile warning sensor and helmet-mounted cueing system. This upgraded F-16V technical foundation provided the technical starting point for Lockheed Martin's next-generation F-16 specifically built for India called the F-21. Not only does the F-21 incorporate active electronically scanned, but the jet also integrates a high-tech, next-generation targeting system called infrared search and track technology. Infrared search and track technology, which is used extensively in F/A-18 Super Hornet fighter jets, is a passive, long-range sensor that searches for and detects infrared emissions. Much like the active electronically scanned, the infrared search and track can track multiple targets at once and operate in an electromagnetic warfare environment. As a passive, long-range sensor, able to provide air-to-air targeting, infrared search and track introduces new combat variables for the F-16. In effect, while there are ultimately limits to how much an older aircraft can be upgraded, today's F-16 is almost an entirely different airplane apart from keeping its basic airframe configuration.